Let's solve this system using Gauss-Jordan elimination. The first thing we'll want to do is rewrite it in our standard form with our constants on one side and our variables in a consistent order. So here we'll get 2x plus y minus z is equal to 1. 2x minus 3y plus z is equal to 1. And last, negative x, negative y plus z equals 4. That's okay the way it is. Now let's write our augmented matrix. So for our x's, our coefficients are 2, 2, negative 1. Then we'll do the y's and then the z's. And then our right-hand side. So our first step, remember in each column, we want to get the 1 first and then the zeros. And so I want a 1 here. And I could multiply the first row by 1/2, but I think it will be easier, since I see a negative 1 sitting very conveniently in the third row, I'm going to switch row 1 and row 3. And so now I have this. Second row still the same. And row 1 moves to the bottom. And now I can multiply my first row by negative 1. The reason this is easier, it just postpones the fractions one more step, basically, which makes the arithmetic easier if you're doing this by hand. Okay, so now what do we want to do? Now we want to get zeros in that first column. So to get those zeros, you take the opposite of that number, multiply by the row with the leading one, which will be the first row, add to the row you're working with. Do the same thing for both of them. Okay, this is what you should get for your matrix after you do those row operations. I've skipped the scratch work and am trusting that you're working it on your own to make sure that you can do them correctly. Now what do we need to do? Now we need a 1 in the second row, second column. So right here, we want this to be a 1. And so we are going to multiply the second row by negative 1. Other two rows will stay unchanged. So now we need to get zeros elsewhere in that second column. So here and here, we want to have zeros. So we take the opposite of those numbers, so that'll be 1 multiplied by the row that has the leading one, which will be row 2, and add it to the row you're working with. Okay, we should get 1, 0, -4, -13 for our first row. Second row stays the same. third row we should get 0, 0, 10, 36. So now we need to move to the third column. We're going to get the 1 first and then the zeros. This needs to be a 1. So we're going to multiply that third row by 1/10. And I think this will be easier if I just do it as a decimal. So we get 0, 0, 1, 3.6. Okay, and now we need to get zeros in that third column in the right places. So these two guys need to turn into zeros. So that means positive 4 times the row that has the leading 1. So that'll be row 3. Add it to the row you're working with, and then back into that same row. And then we'll have 3, row 3, plus row 2, back into row 2. When we do that, we should get 1, 0, 0, 1.4, 0, 1, 0, 1.8, and 0, 0, 1, 3.6 as before. Let's put the vertical line back in and let's write our solution. Our ordered triple XYZ is equal to 1.4, 1.8, 3.6. Now let's see some of the special cases that can come up, just as they did when we had a system of 2 equations and 2 unknowns, and we used Gauss-Jordan elimination. Most of the time we would get one solution, but sometimes we'd get something a little bit different. And that can happen using Gauss-Jordan as well. Let's write our augmented matrix. Like this. Now our first goal is to start with the first column and get a 1 in that first entry. So that means we're going to multiply that row by 1/3. Like this. And now we need to get a 0 right here. And we will do that in the usual way. We take its opposite, so -2 times the row with the leading 1 plus this row, and then back into this row. And so my first row stays unchanged. And then my second row, when I do that, I should get 0, then -4/3, 11/3, and then 17/3. Okay, now we need to move to the second column. We want this to be a 1. So we are going to multiply that row by the reciprocal of that number, which will be -3/4. So -3/4 row 2 into row 2. So that'll give me for row 2 0, 1, -11/4, -17/4. My first row stays the same. Now we need to get a 0 in the second column right here. So we are going to take the opposite of that number, which will be positive 1/3, multiply it by the row with the leading 1, which is actually row 2, add it to the row we're working with, and then back into that first row. When we do this, we should get 1, 0, negative 1/4, negative 3/4, and then we have 0, 1, negative 11/4, and negative 17/4. Okay, so now we need to remember what our columns represent. Okay, we have x, we have y, we have z, and we have our right hand side, our constants. So let's write these rows down as an equation. So we're going to have x minus 1/4 z is equal to negative 3/4. And in the second row, we're going to have y minus 11/4 z is equal to negative 17/4. This is an example of a problem in which we will have infinitely many solutions. And it's not good enough to just say there are infinitely many solutions. We need to be able to write them down. So what we want to do is we want to let one of the variables be any real number, and then write the others down in terms of that. Both of these equations that I've just written down, the first is very easy to solve for x, and the second is very easy to solve for y. So what we want to do is we want to let z be any real number. So then what we end up with is z is any real number. Solve for hang on, let me write them in order. We're going to do x and then y and then z. It really doesn't matter, but we might as well do them in order. So we're going to let z be any real number. Let's solve the first equation for x. And so that's going to be 1/4 z minus 3/4. Just have to add that 1/4 z to both sides. And then my y is going to be 11/4 z minus 17/4. And then we're going to let z be any real number. So this is one way to write the solution. Here's another way that you will sometimes see this solution written, is if we write it as an ordered triple, then my x, y, z is going to be 1/4 z minus 3/4. That's my x. My y will be 11/4 z minus 17/4. And then my z will just be z. And we should make a note that z is any real number. That's an alternative way of writing your solution, your description of the solutions to this system. Okay, and so if somebody wanted to check to see if their answer, their ordered triple, was a solution, all they would have to do is z could be anything, but they could check to see if x and y are what they are supposed to be in terms of z. If someone wanted to generate solutions, they could pick values of z and then calculate the x's and the y's that need to go with them. Let's look at another example. Negative 4x plus 8y is equal to 2. X minus 3y is equal to 4. 2x plus 2y is equal to negative 3. So we write our augmented matrix. Negative 4, 1, and 2 are our coefficients of x. 8, negative 3, and 2 are our coefficients of y. And then my right-hand side, 2, 4, negative 3. And I do Gauss-Jordan elimination. So here, I want to have a 1 here. What's the easiest way to get it? Well, I'm going to switch rows. I'm going to trade rows, row 1 and row 2. Okay, and so now we need to get the zeros in that first column. So we want these two to be zeros. So we're going to do 4 row 1 plus row 2 into row 2. We're going to do -2 row 1 plus row 3 into row 3. Okay, when we should do this, we should get for our first row 1, -3, 4, same as before, but then 0, -4, 18, and 0, 8, minus 11. Okay, now we move to our second column. We need to get the 1 first, and then the zeros. So we want to put a 1 here. So we multiply the second row by the reciprocal of that number, so -1/4 row 2 into row 2. Okay, now we need to get the zeros in that column. So we want to get a 0 here and a 0 here. So we multiply, we take the opposite of that number, multiply it by the row with the leading one, which will be row 2, add it to the row we're working with, which is row 1, back into row 1. Then to take care of the 8, we take its opposite, -8, times the row with the leading 1, add it to the row we're working with, row 3, and then back into row 3. So we should get 1, 0, -19/2 for our first row. Second row stays the same. Third row we get 0, 0, 25. So now we remember what our rows stand for. Our columns, X, Y, and then here's our right hand side. And so all we need to do to figure out what's up with this is we need to look at the third row and we need to realize, what does it say? It says that 0x plus 0y is equal to 25. In other words, 0 is equal to 25, which is definitely a false statement. If you end up with a false statement from one of your rows that can never be true no matter what, that tells you that you have an inconsistent system. Which has no solutions. It's impossible for a point to satisfy all of these equations. So I don't even need to worry about any of the other rows. Now, if I would have had 0, 0, 0 across the bottom row, that's a true equation, and so that's not a problem. So then I continue and write down my values of x and y from the rows above. I hope this helps you with Gauss-Jordan elimination. Good luck, and I